Welcome to The Explainer. Today, we're going to tackle maybe the biggest question there is. Where did all this come from? We're diving headfirst into the origin of our universe, and it is, no joke, the greatest story ever told. Okay, so to really get this, we have to go back, way back. To the very beginning. Try to wrap your head around this. About 14 billion years ago, everything, and I mean everything, all of space, all of matter, all energy, was squeezed into a space smaller than the period at the end of a sentence. It was so unbelievably hot, so dense that the fundamental forces of nature weren't even separate things yet. They were all just one. So the big question is, right, how do you get from that tiny, hot, impossibly small speck, to this? To the massive, sprawling universe we see out our telescopes, just packed with billions of galaxies? Well, that journey, that's the story we're about to unpack. So where do we even start? We have to begin in an era that's so early, so extreme, that our own laws of physics just stop working. They break down. We're talking about a time before time itself, really. It's a period that scientists call the Planck era. And when I say it was brief, I mean it. We're talking about a sliver of time so small it's hard to even write down. It's 10 to the minus 43rd seconds. That's a 0, a decimal point, then 42 more zeros, and then a 1. It's nothing. But in that impossibly tiny flicker of an instant, the entire blueprint for our universe was basically set. Now, this is where things get really tricky for physicists. To understand the Planck era, you have to smash together our two greatest theories of the universe. You've got Einstein's general relativity, that's the rules for big stuff like planets and stars. Then you've got quantum mechanics, the super weird rules for the tiny subatomic world. The problem? Back then, the entire universe was tiny. The large was the small. And when you try to use both sets of rules at the same time, they just don't work together. It's been called a shotgun wedding for a reason. They refuse to cooperate. Okay, so as the universe starts to expand, and I mean violently expand, and cool down from that insane starting point, something incredible happens. Things start to separate. And suddenly, a whole zoo of brand new, fundamental particles just explodes into existence. Think about like the great divorce of the fundamental forces. In way, way less than a trillionth of a second, that one single superforce splits apart. First, gravity kind of wriggles loose and goes its own way. Then the strong nuclear force breaks off. And finally, what's left, the electroweak force, splits into the weak and electromagnetic forces. And boom, you're left with the four forces that have run the show ever since. So now that the forces are separate, the universe is just this chaotic, churning, seething soup of pure energy and particles. It's wild. You've got photons of light with so much energy that they can just spontaneously turn into a particle of matter and its antimatter twin. And then, poof, those two particles would smash into each other, annihilate, and turn right back into energy. It was this constant, frantic storm of creation and destruction. And this soup was just packed with all kinds of characters, a real particle zoo. Physicists lump them into families. You have the leptons, the most famous one is the electron, you know that one. Then there are bosons, which are basically the force carriers, the messengers. And then you have the quarks. These are the building blocks for the protons and neutrons in every atom. And let me tell you, quarks are some of the weirdest little critters in this whole story. Here's what's so weird about quarks. You can't get one by itself, ever. They are like pathologically social. The force that holds them together is like a bizarre rubber band. The more you stretch it, the stronger it pulls back. If you pull hard enough, the energy in that stretched band just becomes so immense that, snap, it creates a whole new pair of quarks right there. So you can try all you want, you will never, ever catch a quark all by itself. So in the middle of all this chaos, there's a universe-defining battle going on. It's matter versus its evil twin, antimatter. And seriously, the outcome of this one single fight is going to decide whether we end up with a universe or just nothing at all. See, as the universe kept cooling down, whenever a matter particle met its antimatter twin, they would annihilate each other. Poof, gone. Just a flash of energy. It was a perfect one-for-one cancellation. And if it had been perfectly balanced, the entire universe should have just turned into a sea of light, with no stuff left in it at all. But obviously, that's not what happened. For some reason, and we still don't totally know why, the universe cheated. There was this tiny, tiny little imbalance, a slight asymmetry. For every single billion particles of antimatter that were made, the universe made a billion and 1 particles of matter. Just think about that for a second. After all the matter and antimatter pairs wiped each other out, that 1 extra particle in a billion was all that was left. That little bit of leftover stuff is everything. It is, without any exaggeration, the most important leftover in the history of time. It's the reason we have galaxies, stars, planets, you and me. Okay, so fast forward a bit. The universe is now 2 minutes old. It's cooled down enough that those leftover quarks can finally group up and form the first protons and neutrons. And then those start to stick together, forming the very first atomic nuclei. We're talking mostly hydrogen and helium. This is the raw stuff that everything else will be built from.
But we're not out of the woods yet. For the next 380,000 years, the universe is basically this hot, dense, glowing fog. It's still too hot for electrons to latch onto those nuclei to make stable atoms. And because of that, light can't travel. Photons just get bounced around, trapped inside this cosmic soup like a pinball. You couldn't see anything. It was totally opaque. All right, now we're going to take a big leap forward in time. We're going to see how those simple atoms of hydrogen and helium, made in the first couple of minutes, eventually become, well, us and everything else we see. This, for me, is where the story starts to get really good. So at that 380,000-year mark, it happens. The universe cools down just enough for electrons to finally get captured by nuclei, making the first real, stable atoms. And just like that, light is set free. The cosmic fog clears. The universe becomes transparent for the first time. Then, over millions and millions of years, gravity just patiently does its thing. It pulls all that hydrogen and helium together into these massive clouds until they ignite, becoming the first stars. And inside those stars is where the heavier elements get cooked up. Carbon, oxygen, all the good stuff. And then, after about 9 billion years go by, our star, the sun, flickers into existence with a disk of leftover dust and gas that will become the planets. And on one of these planets, this one, those elements that were forged in stars came together to form life. And that life, wow, it was fragile, but it was tough. And after so many cosmic accidents, like a giant rock from space wiping out the dinosaurs, one particular branch of that life eventually evolved into a species that could look up, wonder, and actually piece together this whole incredible story. And that brings us all the way to today. We've gone from a point smaller than atom all the way to a universe just teeming with wonder. But, telling this story also brings up some of the biggest, most profound questions we can even ask. So what's the number one biggest question? Well, what happened before the beginning? What came before the Big Bang? And the most honest and maybe the most exciting answer is, we have no idea. Our science hits a wall at that first moment. And you know what? That's not a failure. It's kind of the point. Being ignorant, not knowing the answer, that's what drives scientists to keep pushing, to keep asking. But here's something we do know, for sure. We're not just observers of this story. We are part of it. I mean, think about it. Every single atom that makes you, the carbon, the oxygen, the iron in your blood, every single one was forged in the core of a massive star that lived and died billions of years ago. We are, quite literally, made of stardust. And that leaves us with this one last, just mind-blowing thought. We are stardust. We're the leftover ashes from cosmic furnaces, brought to life and given the ability to think and to wonder. In a very real way, we are the universe, becoming self-aware. We are the cosmos looking back at itself, trying to figure out its own story. And the most incredible part of all of this, we've only just begun.